Welcome to new session of the differential equation. In this session, we will discuss about the method of undetermined coefficients, that is we discussed in the last session also, and this is one of the method that we use to solve non-homogeneous linear differential equation. We know that the non-homogeneous linear differential equation y double dash plus p of x y dash plus q of x y is equal to r of x is one of the differential equation, that is equal to non-homogeneous linear differential equation. Here may be this one, there is a corresponding homogeneous part is there, y double dash plus p of x y dash plus q of x y is equal to 0 is the homogeneous part of the differential equation. And we have we already discussed in many sessions about the solution of the homogeneous linear differential equation, and that may have the solution y is equal to c1 y1 of x plus c2 y2 of x. Here c2 y2 of x, and here this one c1 and c2 are the arbitrary constants, and y1 and y2 are the fundamental set of solution or the basis, and this y is the general solution of the corresponding homogeneous equation. In this case, we may denote this as yh as the solution of the homogeneous part, and this yh is here. And we already discussed it is that the solution of the equation 1 is actually the solution of equation 1 is the solution of the solution of non-homogeneous equation. The solution of non-homogeneous differential equation is actually y is equal to yh plus yp, y is equal to yh plus yp, yh plus yp, where yp is the particular solution that we need to find. Okay. And we discussed it, there are two types of the differential equation that may exist there, and this is we discussed here it is that there is a choice of yp, and we discussed based on the value of r of x we can predict the yp, and this we discussed this is choice of yp, sorry, choice of r of x, and here we have a choice of yp, choice of yp of x. See, dear students, if r of x is equal to k e raised to px, then we say that this is equal to c e raised to px, and we just find the value of this one. We will find the yp dash, yp double dash, and we will apply an equation, and after applying the equation we can find this one value of c. And see, dear students, if this is equal to some Pn of x, this is equal to some Pn of x, the nth degree polynomial, then we can say that this is equal to some kn x raised to n plus kn minus 1 kn minus 1 x raised to n minus 1 plus etc. plus k1x plus k naught, k1x plus k naught. So, that is because if the r of x is the non-homogeneous part is the nth degree polynomial, and we discussed a question in the last session, and we can move to the next question, write down the next example, that is the solve the differential equation y double dash minus 3 y dash, y double dash minus 3 y dash minus 4 y is equal to 3 e raised to 2 t, 3 e raised to 2 t, that is equal to, sorry, 3 e raised to, I would like to write here it as 2x instead of t, I would like to write this as 2x, 3 e raised to 2x. Fine. See, dear students, here we have this is the non-homogeneous equation. I would like to put this as equation number 1. Fine. See, and this is the y double dash, and as part of solution would like to draw the write the corresponding homogeneous equation. Would like to write the corresponding homogeneous equation. This is the corresponding homogeneous equation is y double dash minus 3y dash minus 4y is equal to 0, and we have the r of x. This is the r of x. R of x is 3 e raised to minus 2x. Sorry, 3 e raised to 2x plus 2x is there. Fine, and therefore, to solve this is we can find the auxiliary equation. We can write the auxiliary equation. The auxiliary equation is actually y double dash is there. Therefore, m square minus 3m minus 4 is equal to 0. So, we have to find two values, their product is equal to minus 4 and their sum is equal to minus 3. See, we can write this is equal to that is minus 4 into plus 1 is equal to this one minus 4 is there, minus 4 plus 1 is equal to minus 3 is there. So, okay, no problem, we are happy. Fine. Therefore, we can write this is equal to m minus 4 into m plus 1 is equal to 0. Okay. See, m square minus plus m minus 4m, that is equal to minus 3m, minus 4 into plus 1, that is equal to minus 4. Okay. Therefore, we have the value of m is equal to 4 or m is equal to minus 1, m is equal to minus 1. The roots are real and distinct. Therefore, we can write this is equal to yh. Therefore, yh is equal to, therefore, yh is equal to c1 y1 of x plus c2 y2 of x, that is equal to, that is yh is equal to, that is yh is equal to c1 is the arbitrary constant and y1 is the e raised to m1 of x. m1 is actually the first m we can consider as m1 and the second m we can consider as m2. Okay. Therefore, we can write this is equal to e raised to 4x c1 e raised to 4x plus c2 e raised to minus x, c2 e raised to minus x. Okay, fine. So, dear students, this is our yh and we found our yh and we have to find the yp. See, here we have given it is that 3 e raised to 2x. So, here r of x is equal to find yp, to find yp, here r of x is equal to 3 e raised to 2x. So, k e raised to px is the form. So, say k e raised to px, so c e raised to px is the value. So, we can write this is equal to, since because this is r of x equal to 3 e raised to 2x, therefore, we can write therefore, yp is equal to, therefore, yp is equal to c e raised to 2x. Just we need to find yp dash and yp double dash. So, that yp dash is equal to c e raised to 2x, that is 2c e raised to 2x. Okay. And yp double dash, yp double dash, yp double dash is equal to 2 into 2 4c e raised to 2x, 4c e raised to 2x, 4c e raised to 2x. Fine. So, we have to apply here y double dash minus 3y dash minus 4y. So, y apply in y double dash minus 3y dash minus 4y, sorry, 3y dash minus 4y is equal to 3 e raised to 2x. See, that is our equation. y double dash minus 3 y dash minus 4 y is equal to 3 e raised to 2x, 3 e raised to 2x. So, see y double dash minus 3 y dash minus 4 y is equal to 3 e raised to 2x. Okay. Fine, this is equal to y double dash minus 3 y, we will apply y p double dash is here, that is equal to 4 c e raised to 2x minus 3 c e raised to minus 3 into 2. Therefore, we can write this is instead of this is equal to 3 into 2 minus 6 c e raised to 2x. Okay. Fine, minus 4 into y, is actually y p is actually c e raised to 2x minus 4 c e raised to 2x is equal to 3 e raised to 2x is here. See, we can take e raised to 2x is outside, that is equal to 4 c minus 6 c minus 4 c e raised to 2x is equal to 3 e raised to 2x. See, dear students, here this is here e raised to 2x and e raised to 2x we can cancel, and we have this here minus 4 c and plus 4 c is here. Therefore, we will have finally this is equal to minus 6 minus 6 c equal to 3. Okay, fine. Therefore, minus 6 c equal to 3, therefore, c is equal to minus 3 by 6. This is equal to minus 1 by 2. C is equal to minus 1 by 2. Fine. Therefore, now we found c, the value of c is equal to minus 1 by 2. Therefore, we have y p is equal to instead of c. Therefore, y p. Therefore, y p is equal to minus 1 by 2 e raised to 2x is the y p. Fine. We have we already found y h and now we found the value of y p. Therefore, the general solution of the given non-homogeneous equation is, therefore, general solution of given non-homogeneous differential equation is, that is the non-homogeneous differential equation is y is equal to y h plus y p. Therefore, y is equal to y h is we already found the y h, that is y h is actually c 1 e raised to 4 x plus c 2 e raised to minus x. C 1 e raised to 4 x plus c 2 e raised to minus x minus c here we found y p as minus 1 by 2 e raised to 2 x minus 1 by 2 e raised to 2 x. So, this is the general solution of the given non-homogeneous differential equation. Okay, fine. See, actually we just check the value of the function r of x, that is the function which belongs to the RHS part of the linear non-homogeneous differential equation. If that is exponential function, we can use this method. We just write after finding y h, the complementary function, we just evaluate y p as a c e raised to some p x, here it is 2 x, therefore, c e raised to 2 x, and then we will find y p dash and y p double dash, and we just apply the original differential equation that we have given to solve. So, after applying that one, we can find the value of c, and we just apply the value of c here in this y p, we will have the particular solution for the non-homogeneous equation. By applying the equation y is equal to y h plus y p, we will get the solution of the non-homogeneous differential equation. By using method of the undetermined coefficient, I would like to invite your attention to the next example. Dear students, come to the example. Here solve, see, solve example 3 solve the non-homogeneous differential equation, solve the non-homogeneous differential equation y double dash plus 4y, y double dash plus 4y is equal to 8t square, is equal to 8t square. Instead of t, I would like to replace here as we used x, that is maybe find as to understand 8x square. So, I would like to put this as equation number 1, y double dash plus 4y is equal to 8x square. See, this is non-homogeneous. As part of solution, we can write the corresponding homogeneous differential equation. Okay. The corresponding homogeneous differential equation is y double dash plus 4y is equal to 0. Y double dash plus 4y is equal to 0. See, dear students, we can write the corresponding auxiliary equation. The auxiliary equation is, that is y double dash, that is equal to m square plus 4 equal to 0. We can take this plus 4 to here, therefore, this is m square is equal to minus 4. Therefore, m square equal to minus 4 means m square equal to square root of minus 4, that is equal to plus or minus 2i. Sorry, m is equal to plus or minus 2i, fine. So, we found there are two values of m and their real part is equal to 0, that is m is actually 0 plus or minus 2i. Okay. So, therefore, e raised to p x, the p is equal to 0. Therefore, the general solution is actually therefore, general solution of homogeneous equation or homogeneous part is actually general solution of the homogeneous equation or the homogeneous part. Homogeneous part is actually that is equal to y, that is instead of y I would like to say it is a complementary function, that is y h, that is equal to e raised to p x a cos q x, that is a cos, instead of q here we have the value 2, a cos 2x plus b sin 2x, a cos 2x plus b sin 2x. Okay. This is the general solution of the homogeneous part, that is the complementary function. And dear students, we can write again, we have to find again yp. See, we have to analyze about r of x. So, which is r of x? Come back to our equation, this is our r of x. This is our r of x. So, r of x is a polynomial function. R of x is a polynomial function. As because it is a polynomial function, is a second degree polynomial. R of x is equal to 8x square. See, r of x is equal to 8x square. R of x is equal to 8x square. As because it is a polynomial, we have a choice of yp, nth degree polynomial. Therefore, yp is actually yp of x or yp is actually k2 x square, second, as because this is a second degree polynomial. The highest power is 2, therefore, 8x square k2 x square plus k1 x plus k0 is there. Fine, therefore, we have yp and we need to find the yp double dash and yp dash and yp double dash. So, just have to find the yp dash. So, therefore, yp dash, see my dear students, actually yp dash is equal to derivative of k2 x square, that is 2 k2 x. plus k1, derivative of k naught is equal to 0. Therefore, we can write this is equal to 2 k2x plus 2 k2x plus k1 k1x is k1, derivative of k naught is equal to 0, and just we can find the yp double dash, that is equal to 2k2, derivative of x is equal to 1, k1 is equal to 0. Okay, dear students, now we found yp dash and yp double dash. Okay, apply or put in our equation is actually y double dash plus 4y is equal to 8x square, y double dash y double dash plus 4y is equal to 8x square. Okay, that is our differential equation. See, dear students, we just apply here, therefore, yp double dash, that is equal to 2k2 plus the next one is 4y, 4 into, that is yp. The yp is actually k2x square plus k1x plus k naught. So, just apply k2x square plus k1x plus k naught is equal to 8x square. See, dear students, we can compare the coefficients of x square. So, we can rewrite this is again 2k2 plus 4k2x square plus 4k1x plus 4k naught, okay, 4k naught is equal to 8x square, Oh yeah, fine. Now, we can compare the coefficients of x square. Okay, compare the coefficients of x square. Compare the coefficients of x square, compare the coefficients of x square. Okay, coefficients of x square. So, here we will have the coefficients of x square is 4k2x square, here we have 8x square. So, 4k2 is equal to 8, that is 4k2 is equal to 8. Therefore, k2 is equal to 8 by 4. Therefore, k2 is equal to 8 by 4, that is equal to 2. That is k2 is equal to 2. Now, the next one is to compare the coefficients of x. So, while comparing the coefficients of x, we will have here we will have for k1, there is in RHS there is no part of x. Therefore, for k1 is equal to 0 implies k1 is equal to 0. Now, we found k1 is equal to 0 and for k1 is equal to 0, therefore, k1 is equal to 0. Now, finally, equate the coefficients, equate the constant terms, Finally, we will have the equate the constant terms. So, while equating the constant term, we will have this is equal to the constant terms is actually 2k2 is the one of the constant, 4k naught is one of the constant and 2k2 is the constant. Here there is no constant. Therefore, 2k2 plus 4k naught is equal to 0, 2k2. Finally, we will have therefore, 2k2 plus 4k naught, 2k2 plus 4k naught is equal to 0. We already found the value of k2 is equal to 2 Therefore, we will have this is equal to 2 into 2 plus 4 k naught is equal to 0. Okay. Find therefore, 4 k naught is equal to, while taking this 2 into 2 is equal to 4, that is equal to minus 4. Therefore, k naught is equal to minus 4 by 4 is actually minus 1. Minus 4 by 4 actually that is equal to minus 1. So, dear students, we found the value of k naught is equal to minus 1, k 1 is equal to 0 and k 2 is equal to 2. Therefore, y p is equal to, therefore, y p of x is equal to this one k 2 x square plus k 1 x plus k naught. We found k naught is equal to minus 1, and therefore, the value is actually k 2 x square, that is equal to, the value of k 2 is actually 2, therefore, 2 x square plus k 1 is equal to 0, therefore, the term containing x's will not be there and k naught is equal to minus 1, therefore, 2 x square minus 1. So, we found y p as 2 x square minus 1. Therefore, the general solution of y double dash plus 4 y is equal to 8 x square is, that is, we found the y h, y is equal to y h plus y p, who is actually y h, and y p we have y h is equal to a cos 2 x plus b sin 2 x is y h. Okay. Therefore, this is equal to, fine. Dear students, we have finally we arrived, this is equal to general solution, y is equal to y h is equal to a cos 2 x plus b sin 2 x and y p is actually 2 x square minus 1. Therefore, this is equal to 2 x square minus 1 is the general solution of the given non-homogeneous linear differential equation. Okay, fine. And this is the way we can solve the if the RHS, that is the value of R of x, is the second degree polynomial, and if even if it is third degree polynomial, any nth degree polynomial, that we can find by using these concepts. And okay, we have many methods to solve. We have 4 more methods to solve this one non-homogeneous equation by using the method of undetermined coefficients, that we will discuss in upcoming sessions. Thank you for watching these videos. Continue watching. Thank you very much.